All right. Welcome, everybody. We're going to start in about 2 minutes. If you came from the previous session, then this is actually going to be very relevant because there was a lot of questions about telemetry. Before we start, for me, this is actually a very interesting topic because I've lived with the pain of non-real-time, trying to look at log files, trying to find the needle in the haystack for production systems that are a mess. I spent a sleep-deprived weekend in Monterrey, Mexico 20 years ago, trying to find out why a production system was crashing in real time because we didn't have any tools. We couldn't really find out what was happening. Team of 10 of us all looking at log files like maniacs. So thankfully, nowadays we have OpenTelemetry. We have a standard for actually monitoring things in real time. And now with both App Connect and webMethods use this. So today we're joined by Ravi and Ben, who, if you've seen over the past couple of days, have been joining us to talk about how OpenTelemetry is a key part of observability, real-time observability, thankfully, in both of the products together in the IBM integration suite. So with that, I'll hand over to Ben and Ravi.
Thank you, Frank. I don't know about anybody else. I think I just want to hear more about Frank's anecdotes and these production systems that were down. That was brilliant introduction. Thank you for that. So what we're going to do today is, as Frank said, it's a bit of a double act. So we're going to focus first of all on App Connect Enterprise, and that's why I've got the floor to begin with. And then I'll pass the baton on to Ravi, and he will pick up probably after about 30, 40 minutes or so, something like that, and then cover off the webMethods side of the conversation. And with a bit of luck and a tailwind, we should finish with enough time for maybe 5 or 10 minutes questions at the end, but we will see how things go. We've got live demonstrations today, so you never know quite what's going to happen. So without further ado, let's crack on with the content. So part one, and we're going to start easy. We're going to start by describing what this thing called OpenTelemetry is all about. And then we're going to go into a little bit of history in terms of how the ACE product supports OpenTelemetry. Then we're going to see some nice flashy demos and some examples if everything is working well. Keep your fingers crossed. So OpenTelemetry. Observability, if we start with that term, has actually been around for quite some time. In fact, as long as integration middleware has been around. But what OpenTelemetry is specifically is what's known as an incubating project. So within the Cloud Native Computing Foundation, they sponsor a bunch of open source initiatives. And there was actually a couple of previous projects, one called Open Tracing, which dates back to sort of circa 2018, something like that, and another one called Open Sensors. And they merged these together in order to create this thing that's now been christened as OpenTelemetry. And as you can see on the chart here, it's basically the CNCF has a few different statuses or maturity levels, as they like to call it, which essentially helps guide users about whether the technology being discussed inside these projects is ready for mainstream adoption yet. And in the case of OpenTelemetry, it's what's known as incubating. So it's already moved up from the adopting level, and it's actually now in a good state where it can be used genuinely for production use cases. It's got widespread adoption with a lot of different vendors. So what is OpenTelemetry? Well, at its heart, it's a bunch of different standards, right? It's a collection of APIs, SDKs, so it involves code as well, and then tools. So if you were to go to the CNCF website and start digging around in the OpenTelemetry project, you'd find that there's a bunch of vendors that like to advertise their wares with interoperation with that standard. And the dream that's being sold here, of course, is that if you choose one particular vendor and tool, you're not locked into that choice forever. So if you decide that perhaps Instana isn't for you, I really hope you're not in that position, but in the unlikely event that you're not happy with IBM's solution in this space, maybe you want to move to a different vendor, it should be relatively easy for you to do that. So in terms of the data structures on the wire that are used, the concepts, the tagging, the attributes that are applied to the data as it goes between the different parts of your architecture, that should be consistent regardless of which vendor you're talking to. And that can also help when you're actually implementing the standard as well. So in the case of App Connect Enterprise, we actually take one of the OpenTelemetry SDKs, we embed it within our C++ engine, and we then use that in order to distribute the data. So there's a classic example where we didn't have to write code to model the individual bits and bytes on the wire, and we just took that SDK and we got a large part of the architecture essentially for free as part of doing that. So what are the challenges? Well, obviously learning about the standard to begin with. Performance is a big challenge in this case. As I say, we are ready for production status. And when I talk through the different bites of the cherry that App Connect has had, one of the reasons why we moved from one style of architecture to another in order to support OpenTelemetry was really all about performance. And if we compare OpenTelemetry as a standard to some of the previous kind of techniques that people had for observing data as it flows, one of the big differences is that with OpenTelemetry, when we send the traces to the collector and to the back end, they're very small in size. So we're trying to maintain this position where the HTTP transport or the gRPC transport where we submit that data, it only has very small packets to describe the individual spans of behavior that happen within each one of the products. And by keeping those pieces of data small, it enables the standard to be a very good, smart fit for production systems. So at the very bottom of this chart, what are the different areas of OpenTelemetry? Well, people often talk about metrics, logs, and tracing. I think somebody injected alerts there just to make the acronym easier to pronounce. So MALT, perhaps, metrics, alerts, which is the most recent part of the standard, logs and tracing. We're going to concentrate mainly today on the tracing part because this enables us to track individual parts of the data as it goes through the enterprise. But of course, the standard also helps you out with log entries that might tell you if the system's thrown an exception, that kind of thing. And when we talk about metrics, we're really talking about time series data. So things like within this period of 20 seconds, how is my product performing? How many messages per second are going through it? That kind of idea. So very close interlock between this presentation and the one that you saw earlier from Tim Dunn, where he was going through some of those performance best practices. So hopefully this is a good follow-on topic. The three main parts to OpenTelemetry that are mentioned at the bottom there is a nice little lead into the next chart. And so this is one of the diagrams that OTel has up on their website. And aside from showing some of the main kind of back-end systems like Prometheus and Jaeger, which are two of the big open source approaches to actually running a back-end that can be used with OTel data. Aside from that, the other things to point out on this chart are the exporters. So an exporter in this architecture is something that actually exports or sends out traces describing the activity of the program that it's coming from. So in this case, ACE is fulfilling that role, webMethods will be fulfilling that role when we're talking about the architecture. And we've also got processors that are capable of receiving that data and then perhaps transforming it slightly or embellishing it with further information in order to then push it onto a back end. So that might be in a collector component, it might be in the back end itself. Different products choose different architectures. In the case of Instana, we're going to talk about an Instana collector and then the Instana backend. So in our architecture, there are two different parts to that architecture that communicate with one another. So this is the overall kind of look and the lay of the land. But if we dive in a little bit and start thinking about how is it that data actually flows between these different components, then it will become clear some of the differences between OTel as a technology and perhaps some of the other precursors. So in the case of App Connect Enterprise, one of those precursors we call Business Transaction Monitoring, or BTM for short. And what BTM was really all about was publishing data, normally over MQQs, but it could also have been sent over an MQTT transport. And that data that we published held inside of it all of the payload of what was actually flowing through your system. And we had quite a complex structure as part of the product that could then take the data off a queue, inject it into a relational database, give you lots of nice views that could show you what the payload looked like, also enable you to do replay and re-inject the data through existing flows. But in all of those cases, they were really kind of payload dependent. So it's quite a heavyweight method of monitoring. And if we compare that to what OTel is doing here, when the client first communicates with the application where we're going to be exporting these OTel traces from, that client may or may not have been instrumented with OTel. So in the simplest situation, let's just imagine that client is perhaps, I don't know, it could be curl, for example. It could be SOAP API. It could be a bunch of different programs that are basically just sending an HTTP post or an HTTP GET to a backend. And then the first part of the architecture that knows about OTel, it will choose to christen that data or baptize it, whatever term we want to use, give it a value for the first time that identifies the trace context. And the trace context essentially is an identifier that lets you then hook other traces, other spans all together to give yourself one joined up picture of what's going on. And in the case of App Connect, what we do there is we use this OpenTelemetry client tracing library in order to propagate information out of the product. So in this sort of wiring diagram at the bottom there, often when we look at ACE pictures, we've got these different nodes in a message flow, the discrete stages the data goes through as it's processed. And commonly, we have these traces coming out for particular nodes in our flow. We don't do it for every single node that is within the ACE product. We've focused on specific ones that are all to do with serializing data over a transport. And in particular, the transports that we currently support have been very carefully picked because they work well with OTel. And what do I mean by that? Well, because we're sending data around that has to have these identifiers in it, the most convenient transports for OTel are those that have some concept of a header structure and also the concept of variable length data that can be carried within that header structure. So we're going to be talking about MQ as one of the examples today. And as many folks on the call will know, an MQ message has an MQMD header on it, which is fixed length, but it also has an RFH2 header. And it's that RFH2 header where we put some of the span data so that it can be variable data. Anyway, we're getting ahead of ourselves a little bit here. So let's just focus on the other parts of the diagram. So after we've sent out these values to the OpenTelemetry collector, it's the responsibility of that component to ultimately send it to our observability backend. So in the demos today, we're going to be using, amongst other things, an Instana backend that represents the top red bar on this chart. The OpenTelemetry collector itself, in my demonstrations, that's going to be running as part of a daemon set on 3 different physical workers that make up a Kubernetes OpenShift system. So in that particular mode, you can run this collector either on the same physical machine where your application is running, or you might choose to have it in a gateway mode where you can have multiple collectors running as standalone services and then maybe talk over the network to those separate collectors. So it's very flexible here in terms of your networking topology, how many of each of these components you would prefer. But when you're running in Kubernetes, it's a very logical thing to basically have one on each one of these physical nodes so that it becomes the easiest way of then making sure that wherever you're running inside containers will successfully be able to have the data sent across and be sure that you're not going to lose anything. So whatever runs on those physical workers, whatever containers you're talking about, there will be an example of one of these OpenTelemetry collectors on that machine. So if I move on to the next chart, when we're talking about this data, it's a little bit of a boring chart, this one, but it's very useful in queuing up some of the diagrams that we're going to see later on. So overall, when we talk about this trace, this concept of a trace, that's really describing all of the activity that happens in what we commonly would refer to as a transaction. Now, that doesn't mean a computing transaction in terms of a 2-phase commit transaction or a database interaction in that sense. This really just means a bunch of things that are interrelated that can happen on different physical machines across your network. They can occur within different separate applications. And within the trace itself, we've got multiple spans. And as you can see with the different horizontal lines as they decrease in size as they come down, a span can have overlap with another span. If we think about that core example where you might have an HTTP client coming into a server that's maybe opened up a URL fragment for you to invoke, that client is going to hang around until the HTTP reply comes back to it. And when the backend application receives that HTTP request, maybe it's going to have multiple other things happening. It might put a message on a queue, which is exactly what we're going to do in one of our demos. Maybe it's going to invoke other apps. Maybe it's going to call a backend database. There could be lots of other things going on here. And each of those separate activities can be modeled via a span. So when we send data between those different parts of the architecture, we want to inform the next guy along about what the trace identifier is, and perhaps declare what we're doing is linked to the previous span that was already part of that trace. And you can see that we can do that with these vertical lines being childs or children of previous spans. And you can also link spans together. So where I've got the follows from line, that's an example of a linked span. Now, where ACE is concerned, we don't actually use the link spans, we use the child spans in order to send our data across. But those are the 2 main concepts that the standard has, and individual vendors can choose how they utilize those different span kinds. That's probably all that we need to say on this one. We're going to see some examples of this. So when we talk about the different attributes that can carry, so things like the name of the span, its status, time-related data like when it started and when it finished and all that kind of stuff, we'll see some examples of that in a bit more detail when we're looking at the real systems. So given we've talked conceptually about what OTel is and how the standard works, let's dive into a little bit of stuff on ACE. So App Connect Enterprise, our latest version of ACE is actually version 13, but our story with OTel winds back quite some time, back to circa 2020, where in ACE version 11 at that time, we basically introduced what we call a transport tracking user exit. That's a bit of a mouthful. But what that basically is allowing you to do is when you design one of our flows and you wire the parts together, if you'd like to contribute your own code, your user exit, we can execute that within our engine, within our process, but in between each one of the nodes that make up the message flow. So it's really a way of you writing your own exit code that sits in the middle of what ACE is doing. And normally there isn't really a need for you to write your own code in one of these user exits. You can already write Java as part of a standard flow, for example. You can also contribute your own nodes into our flow palette. But why you might want to run user exits, if you're a tool vendor, it gives you a nice little hook point. It actually gives you a callback mechanism in C++, which enables your code to then get executed. So the reason why we put this interface layer in specifically related to transport tracking was it gave us a nice way of allowing tool vendors to be able to write the user exits themselves that were responsible for sending those OTel traces to the third-party systems. So it's a nice little way for us being able to support other people in contributing code to run inside ACE. But of course, all great ideas have downsides as well. And the problem with a user exit is that its performance profile isn't quite as good as if everything was running inside of our own engine under our control. So we have a lot more control about what happens on the message flow thread and off the message flow thread if we're writing that under our own steam. It also enables us to write very performant code as opposed to some vendors whose code might not be the best. And it also enables us to make efficient reuse of all of our existing parsing technology that we've got within the product. So given the high performance nature of what we're talking about here, it became clear after a while that really we wanted to bring things back in-house and provide OpenTelemetry as a core feature out of the box with no need for these user exits. So we did that in ACE version 12. And as you can see with the various different versions that are mentioned in the detailed bullets, we had a few bites at this. So to begin with, we supported Linux on x86 platforms. We then extended platform coverage to Windows and Z-series Linux in 12.08. And then we extended again for AIX and PowerPC Little Endian into the P-Linux platform. So we've now got full platform coverage. So all of the different flavors of ACE, you have this capability. We've also looked at different transports. So you can see the bullets in the center of the chart here. They're listing out all of the different transports that ACE utilizes where OpenTelemetry is concerned. So basically everything that's MQ based, everything that's HTTP based, both REST and SOAP as well, and our callable flow nodes as well. Callable flows, for those that aren't aware, is a built-in method of transport, which essentially enables you to invoke one flow from another using a connection which is secured. And we typically use callable flows when you're connecting up an on-premise system with one running up in the public cloud. It's enabled you to develop anywhere and deploy anywhere. But the callable flows themselves, they're actually really under the covers. They're using a WebSocket interface. So what's actually happening is we're doing a mutual authentication handshake between two different systems. We're then building a pipe between them, and we're sending that data across the pipe. And what we can send in the case of a callable flow is essentially a serialized form of the tree structure that we hold in memory as we pass it from one node to the next in a flow. So if you like, it's kind of like a proprietary transport mechanism that ACE has for its own flows to communicate with its own flows. So those are all the transports we support. And the last thing on the chart here is in the very latest mod release of ACE in 13.02, we've also added an extra basic security identity into the header of these OTel messages as well. For a long time prior to that, we had full support for certificates and doing everything using a trust store, but then we've just added that basic auth option in there as well. So let's move on with life. I mentioned this transport tracking user exit, and because this is the older technology, I'm not going to spend long on this one. I just literally wanted to throw this picture up and mention one thing which highlights one of the reasons why the built-in support is better. So on this chart, all of the yellow boxes, they're basically saying invoke some code after each of these nodes. So for example, when the first one is called, when it's on transport input message, what that's doing is it's going off invoking the exit, and it can christen the data with a span, with a trace ID. One of these things with this approach means that data has to be passed in our environment tree between the nodes that you've got up here. And that's a bit of a pain for some flow developers, because then they're actually going to see what that span data looks like when they're developing a flow. And if they're silly enough, they can also cause some confusion by deleting that data as well. So it was really carrying the spans in this example as kind of an external of the product, so the user would see it within their message flow. And that's in contrast to what we do with OTel. Now we've got it supported built in, where you don't see those IDs as a flow developer creating your flow. It's all just handled for you at the point where you switch on the OTel support and data goes over the wire. Now, having said that was a negative associated with the prior user exit situation, I'm also going to mention one positive that's associated with that user exit. And to do that, I just wanted to throw up this picture that sort of as a point in time statement that shows how these architectures were working previously. So in this example, we've got a mixture here of, on the left-hand side, the middle arrow is showing gRPC and JSON being sent over HTTP. That's OpenTelemetry formats I'm talking about there. But we can mix and match that with Instana proprietary formats over here on the right-hand side as well. So Instana, as an observability technology, that existed long before OpenTelemetry was ever thought about or dreamed about. So some users might prefer to use the Instana proprietary data in order to link up what's going on in their architecture. So Instana gives you both of those options. You can use its own method of sending data, or you can use OpenTelemetry. And in this case, the MQ queue manager that's involved here is just showing a variance there of these two different methods. And I mentioned a moment ago there was one advantage to that user exit solution, and here I'm going to talk about what that is. Now, there are some transports, and you heard me mention it earlier on, that are not particularly suited to OTel. And those are those transports that don't have a good header structure in front of them. So if you're dealing with file data or TCP socket data, there isn't really a natural header structure that you can flow with that data. Another example of that is a CICS communication where you're making an IPIC connection into a CICS backend. Now, we wanted to be able to support OpenTelemetry on mainframes with CICS applications, and we also wanted to link that together with what's running inside ACE. So one of the things that we did here was we basically injected another kind of user exit that can run as part of the CICS request node, and that enables us to send data directly to ZAPM and the CICS collector so that it can fill in the gaps of the extra identities that have already been created that are flowing through the ACE message flow. So without wishing to dive into all of the gory details here, this is a key example where we've got particular endpoints that haven't yet enabled OTel, but are already part of a very rich network of observability. And because we've got this user exit solution as well, we can still link them together. So that's kind of helpful if you're in a world, and let's face it, in integration, we're often in this universe where you have kind of a mixture of old technology and new technology. So worth just bearing that in mind, that if you come up against a situation where you want to start playing with OTel, but you've got some existing technologies, never fear, you can get the two to work together and everything can nicely interoperate. So we're coming up to demo time very soon. So just to lead into the demo, what I put up here is some of the configuration that you have when you tell an ACE integration server that you'd like to use OTel. And we're looking here at the detail of a server configuration YAML file. Basically, this YAML file defines the personality of your server. It gives you a whole bunch of different parameters that you can tweak to change the server's behavior. And most of them on here really speak for themselves, and you can read the comments yourself at leisure. But the key thing here is that you've basically got one very big on-off switch right at the top, OpenTelemetry enabled, true or false. The next couple of things down, those are examples of attributes that get injected into the spans. And if you don't like, for example, your host name, you'd like it to appear as something else, you can override that using a new setting. You've then got a couple of exporters, and out of the box, we support both gRPC and HTTP. And we've actually got a third one. I'm going to use that in my first demonstration, which is essentially just a file output stream writer. And that's really handy if you're not actually in possession of a testing utility yourself, and you'd just like to see the kind of data that ACE would send out if you happen to be in possession of a gRPC or an HTTP endpoint. So just bear that in mind. That's the first thing that we're going to show in the demo when we get there in a moment, showing what that file output looks like. A few things, just sort of footnotes, if you like, on the ACE support. So when OTel is enabled, we've got these trace parent identifiers. They become part of the transport header. So we've mentioned the use of the RFH2 header, for example, with MQ. You can also turn off OTel for a particular flow. So if you turn on that big on-off switch I was just referring to at the server level, you can then tweak whether or not you'd like particular flows to be part of that environment or not. So individual flows have an off switch if you'd like to use it. The mention of sparse spans relates to situations where you don't necessarily have OpenTelemetry supported by a particular transport. So if, for example, you were driving a message flow with a file input, there's no way that that input file could carry an OTel span as part of the file. So the first thing that ACE does, regardless of which transport you're triggering a flow with, the first thing we'll do is we will create that span ID in readiness in case later on in the flow you are using a transport which is OTel compliant, and you would therefore like to link the activity of that particular node in the flow to some kind of global setting. Obviously, when people think about their architecture, they often think about message flows first. So it's quite nice to be able to link all the activities in that flow underneath one span ID. So we create that span ID regardless of whether you're using an OTel supported transport or not. And that's really what sparse spans are all about. Last thing there, we've also got a unit testing framework within ACE. And when you're running flows and testing flows in that unit testing framework, you don't need to go through all of the complex start procedures that are required in a production server. So in that situation, you don't necessarily have all of the spans being generated because you don't really have an input transport in that case. Here we're doing unit testing, so we're injecting a logical tree directly into a very isolated part of a flow without the need to go over a transport. So in that particular case, we don't generate that telemetry information, but again, we rely on those sparse spans in order to make the flow still perform in the same way so that you can still test whether OTel is working successfully with your unit tests. Right, that's probably enough chat. I will come back to the charts at some stage when we actually get to the flows. But let me begin with a simple example. I'm going to hop back and forth with the PowerPoint today, but to keep everybody nice and interested and focused, the first thing I'm going to talk about today is inside my toolkit here. So this is just a localized test on my local Windows server. Got lots more exciting things to come with the other sections later. But what we've got first of all here is I've got in recording mode a couple of flows, and one is going to invoke the other. And they're running in a server that has a server configuration YAML document set up already, like the one that we were just talking about. So if I just do a search for telemetry, and we come in here, these are the settings that we had a moment ago that we were looking at in the PowerPoint. And you'll notice that one of these lines uncommented here is basically pointing to an exporter, which is just on my file system. And what that means is that if I just pump some data through this message flow, and I can send any old thing in here. So I'm just sending in Ben Thompson, my name, and I'm getting back a hello world message. What's actually happened here is I've sent that into this flow here, and this flow has then called to a second flow. So very simple, straightforward example of just one flow calling another. But why we just wanted to put that up very quickly is then I can go into my directories on the file system here, and I can have a look inside this text file. And this is a nice little way that we have of looking at what those attributes are that have been sent across. So in this case, I'm looking at the second one of those two flows. I've got the trace ID and the span ID that we were talking about, and we've got a trace state that gets carried across. You can see in the attributes section, we've got a whole host of additional pieces of information here. So this is showing some things like the status code that HTTP flow responded with. You can see the names of the individual nodes. You can see the name of my machine there. So a nice little debug aid if you're ever getting up and running with this technology that lets you see inside those OTel messages, even if you don't have a localized server running. So with that, I'm just going to pump back to the PowerPoint demonstration, if I can get the right window, that is. In fact, let me just, I've lost my second screen right now, so this is going to make for interesting viewing. Bear with me one second. Yeah, life's not going to help me today. So instead of that, I'm going to do something slightly different. We're going to go to the next stage of my demo. So fortunately, I happen to have the message flows that are involved today actually here locally inside my toolkit. So the scenario that we're going to deal with here is a couple of different message flows. This is an HTTP driven flow, and it's going to write out an MQ message to a backend. We're going to invoke this flow in a moment. And the way that we're going to invoke this flow is by sending it a very basic message, which is going to have my name inside of it and some personal information. And it's also going to include my voting intention. Now, I don't want to offend anybody politically today, so there's going to be two different voting intentions, either A or B. So you can choose what political party or affiliation or football team or soccer team that might represent. We've just got these two affiliations. And when that data is then sent to a back-end application, it's the job of this back-end application to essentially update the current count in memory of how many votes have been made. And it's then going to send a response message back saying, here's the timestamp, I've recorded your vote. But what isn't sent to that back-end is any of the personalized information. So the idea here basically is to avoid us needing to have this situation where the back end can remain anonymous with the front end not having to be anonymous as well. So what that enables us to therefore do is to send that data across. In fact, I think if I've just brought that out of sleep mode, I should be able to hopefully now actually go back to my charts. So let me do that now. And I'm going to have to just switch my display settings back again. And we can see that a little bit more graphically. So we've got the data coming in over JSON. We've got this message going across the back end with a voting intention. And then when that comes back, it's going to come back the other way with my voting intention, and then ultimately with the processing time. So we've got several different flows going on here. And what we're going to do is see all of that and put some hops through, and then be able to go and look at it inside our hotel backend transport and see how that's worked. So if I bring up my command prompt here, I'm going to have this one here, and I'm going to start off just by looking at what the current vote counts are. So I put a few votes before the presentation today, so we can see at the moment 5 people have voted A, 6 people have voted B. If I clear the screen, what I'm then going to do is I'm going to invoke my backend service, and I'm going to pass in maybe an extra vote for B, and I'm going to be Joe Bloggs, that typical name. So this is a good sign. The service has immediately come back to me and it said, thank you for voting. Your intention has been successfully registered and it's been processed. And if I move from there to actually look at what's going on here, this is a live backend which has been rigged up to look at all of those systems. And I thought this might happen. What's happened here is essentially when the data is sent through, it sometimes takes a couple of minutes to first appear within the chart. So what we're going to look back at is the last 30 minutes or so. Maybe you have to go back to the last hour. And at some stage, when that data is updated, you will actually see that come through and we'll see an up-to-date blue bar. But in the interim, we can go back and look at one of the calls that were made previously because they're all exactly the same. And what we can do here is we can apply some filters at the top of this screen. So this blue bar is representing the call that I made coming into that flow. And the call itself was to this coordinated request reply request flow. So by clicking on a single one of those transactions, I'm now given one of those span views that you could see us conceptually show earlier. And you'll note here that there's been several different calls that have been made. Now, each one of these diagrams, you can look at it in 2 different ways. At the moment, I've got it colored via technology. And what this is essentially showing is that the first one of these flows, because it's driven by HTTP, this has been colorized a slightly different shade of red to the others, which are all coming with messaging as their transport. So beyond that first flow, everything is really MQ driven. Other things to notice here, in total, there have been 13 subcalls. That's quite a lot of calls, but that involves not just one flow invoking another. It also involves an interaction when we put a message to a queue or we get a message for a queue. And you can also see here, we've got a time of duration of 17 milliseconds. So this is a pretty fast flow that we've got going on here, going through some hops and to a back end and then coming back the other way. And if we scroll down, we can see what each one of those hops was. We can actually drill into it and we can expand these different items. And for any individual item, we can then go and look at that data and we can dig into it in more detail. So if I just go back here for a moment before we go back to the other chart and scroll down the right-hand side, you can see the examples of all of the tags that are coming with this data as it passes through. If again, I switch back to my PowerPoint, then it enables us to get a bit of a better overview of how all of the tagging is working. So again, I'm just going to pull up a slightly different chart and we're going to be able to see what those tags look like and all of the different stages that were involved in the flow. Again, if I switch my display settings around, we can see this a lot better. So these are the 13 stages that we saw listed out in the UX just a moment ago, the 13 subcalls. And I've given them different colors here. Some of them are yellow and some of them are pink. And that's me annotating the PowerPoint here. So basically shows which ones involve an ACE flow and which ones involve MQ flows. Now, there's obviously a lot going on here, right? We don't have to go through every single step, but it might be worth just looking at a couple to begin with. So these are all kind of chronologically what's going on here. So item number 1 is where we first invoked that flow. And it's the job of that flow to store some data away on this queue. And that's an MQ put that's happening from this MQ output node. Now, eventually that is going to get gathered back in again. So there's 2 different ways that you can view the relationships here. You could either view that based on what the message queue is and say, okay, somebody's put to the queue and then someone's got from the queue. So I'm going to link them together that way. Or alternatively, you could link the behavior between the ACE flow that's doing the MQ get and the actual MQ get that you issue against the store queue. So depending on your preferences, there's all kinds of different ways that you can then visualize that inside the Instana tooling. So lots of different things that you can do there in terms of how it's coming to pass and how it's being shown to the user. I'm just going to go back to my browser for a moment, and I'm just going to do the back button, and that should take us back. And again, just so you know that there's no smoke and mirrors, you can see that 4 minutes ago, it's currently 7 minutes to 5 in the UK, and you can see that 4 minutes ago, this was that request that went in. So it's been shown correctly to have gone through my system. And when we were just looking at the older ones, it was one that was further back in time. But it just sometimes takes around about 30 seconds to a minute. And I was aware it was going to do that on the call today. So I just wanted to let everybody know that it definitely came through. There's nothing being hidden here, and we're definitely making those calls, and everything is appearing nicely within the dashboard. At this stage, I think it's probably best that I hand on. So we've got to 5 to the hour. So I think that should give Ravi plenty of time to cover up his 20 minutes and leave us for some questions at the end. So if there have been questions in the chat, I will take those whilst Ravi's doing his talking, and we'll see where we go from there. Do you want to take the screen share, Ravi?
Yep, perfect. Yep, we got it. Thanks a lot for that, Ben. I appreciate it. You did some of my job, obviously, so I'll have a quick review of what you covered with OpenTelemetry and talk about its relevance with webMethods and what we're doing here. In terms of OpenTelemetry, you've covered this point already, so obviously the initial 3 pillars when it was introduced to me was tracing, metrics, and logs. And you mentioned that they introduced alerts more recently. And our approach with webMethods is very similar. We start with the tracing concept, and we've actually naturally started there because of some history. So I'll go through that with you guys. OpenTelemetry, in terms of its usage within the webMethods sphere, really started with something we call end-to-end monitoring. And end-to-end monitoring is a solution for our SaaS offering that specifically tackled cross-solution visibility when a transaction, for example, comes in via an API, but then there's some integration work done, logic applied, and then B2B is involved somehow. All of these different integration capabilities, while we provide solutions for them, the tricky part was customers having to look at each of those solutions to get an idea of what's happening with their transactions. And from a telemetry perspective, our application for end-to-end monitoring allowed traces collected from all of these various places using an agent-based approach, really to centralize the information in one place and be able to visualize where things are going wrong, and also even in the green path, understand how much of something is happening across the enterprise. So it's really our initial utilization was to use it to power this end-to-end monitoring capability. Now, when you look at it, more in detail, you can see the value behind it, obviously, because you have various capabilities and tracing happening across the workflows that you've created. You can understand what's taking, what duration in terms of executions, and it really allows you to drill down into all of the various things that your transactions are having to go through, and understand where maybe some bottlenecks are, things like that. So we really were able to take advantage of the distributed tracing capability that's had been long since introduced, much earlier in this offering in terms of our SaaS offering to do this work. Behind the scenes, how it worked in this diagram, you can see it's an agent-based approach. So regardless of where we were hosting and what we were hosting for our customers, we would have a gRPC connection talk to a collector. And we previously used also skywalking for this, and also from a collector perspective, we would use for the data store Elasticsearch, and that data store would allow us to do all the visualization that we needed to show the transaction and fire alerts based on if things are going wrong in specific places. All of the work that we do for end-to-end monitoring was capable of happening because of the edge labeled 1 here. We wanted to take that data that we have today and be able to do trace redirection, right? So trace redirection means take the same trace information that we've been able to take in and understand and collect and provide value, and allow customers to take it and do what they would like with it as well, right? So, and obviously from our perspective, there are several different destinations for that customers would be interested in. One is a completely custom data store. For example, if you wanted to write your own set of Java classes dealing with the processing of the traces singularly, as well as the transport of the traces, you could do that with our framework. And we are able to allow customers to completely target something very custom in terms of what they do with the tracing data that's been collected. We also have standardized connectivity with Kafka. So you can use Kafka if you'd like to do that with a specific topic set, and we're able to publish as needed. Or more popularly, APM tools. So these observability platforms, including Instana and various other Dynatrace, New Relic, we have support for various APM tools out there, and a lot of them support OpenTelemetry protocol, and that's how we get the Instana support as well. And we are able to do this because of the standardization that's around OpenTelemetry. So with all this said, I think it's important to look at things in action, as Ben very well demonstrated. So let me show you some things here. Let's start here. Okay, let's go ahead and log in. This is obviously integration server. I'm going to hit the login here. It's a simple password. It's the standard password that we use. Before I get into the services themselves, all of this is obviously very well documented in our transaction monitoring enablement page. And like I said, it's really tied to that end-to-end monitoring capability that we have, but we're allowing users of existing on-prem solutions, software solutions, to also use the same agent for on-prem work where they have a large deployment of integration servers or API gateways that they would like to do the same work and use the tracing to do redirection to a different source. So it's really the same agent at the end of the day, but we have it capable of being able to be configured to send to those other destinations that the customer requires. So that's how that works. In terms of our integration server UI here, I'm going to just fire off these services to avoid the issue that Ben ran into, which was, it takes some time to get the data going. In the corner of your screen here in the share, you should see a live count that shows for the last 10 minutes, what's happened. And it's tracking both webMethods as well as the ACE calls from earlier. As you recall, there were some calls made, so you might be seeing some counters on the bottom left that are changing as I'm speaking, and that's just showing you that we're right now instrumented to the same Instana instance. So you'll see those numbers change live as we go through this. Let me just fire it one more time, just for good luck. And those numbers should keep going up as we progress through this demo. I'm going to try going back now and showing how this is configured, just so that you guys get an idea how easy it is to get this configured in our environment. Let's do this. There we go. This shows a container that's actually running. You can see there's a demo container called WM TechCon Hotel. And we currently have that running, and that's what's doing the work that I just logged into and fired off a few demo service calls, right? In terms of how it's configured, it looks like any other Docker file. There's several things that are configured, information provided. And most importantly, our end-to-end monitoring agent requires certain environment variables to be set, and that you can see here. You can see the hotel endpoint for the specific, instance and region that we're using for the hotel endpoint for traces. This is actually a standardized structure at the end there, and you can see various custom sort of attributes that we've assigned. I've chosen a service name called test service for all of the transactions that are being communicated over to Instana, so that we have a combined sort of name. And if I flip back over to Instana, I should be able to see. See here. Oops. Looks like you can see the live count there going up, up to 16 total calls, 10 from webMethods. So let's take a look at what's happening in Instana and what we see there. And flip over here. And you can see very similar kind of view of the same service name that I called earlier, and the span view that Ben also highlighted how it works in terms of being able to see any specific nested calls, etc., how long they took. Obviously, this is running off of my laptop because there's a pretty high delay in terms of where my container is sitting and probably where this service is sitting from what Ben's fired off. There is some crossplay. We were going to show more crossplay, but the same voting service is actually what I'm calling behind the scenes. So when I call this service, you should actually see both counts in the bottom left corner kind of increase at the same time because they're actually interacting with each other. And you can see that there's crossplay in terms of the service that Ben created for his demo and this service that's been created for the demo as well from a webMethods perspective. And in terms of our general sort of approach to this, our goal, right, is to have customers to be able to take this tracing data that's capable of being generated and very easily configured, as you saw from a webMethods perspective. It's a very easy configuration through environment variables and the end-to-end monitoring agent that you're able to expose this data to wherever you want it to be. And we want it to be, available for our customers and very easy to configure, right? So that's our focus. And if I go back to the presentation real quick, that ease of deployment, like I said, was our key sort of ask when we went down this path. And our support in terms of what we support our API gateway product, integration server, as well as our microservices runtime product on the broad set of operating systems we support. And it's all done through a package-based approach. So in the webMethods world, packages are reusable and extremely easy to deploy. So we have provided it as a package that utilization of that end-to-end monitoring agent can be very quickly done for existing customers with older versions or newer versions of the software. So I think from my perspective, I've covered sort of the main points that I wanted to cover, and also kind of tried to allow for some time for questions and so on. So let's open up for that. Whenever we're ready, let me go back and take a look at the chat as well. Let's see. And stop sharing here. Okay. Do we see any questions? Oh, Ben, you were handling the previous question. Okay.
Covered. So I have a question. So if a customer has both ACE and webMethods, what's the preferred approach for real-time observability?
Go ahead, Ben. You can start. We don't want to talk over each other. Oh, I think you're on mute, Ben.
There's always more than one mute button. That's my problem. Yeah, so good question, Frank. I mean, I think the answer is it depends whichever technology you're most familiar with. I mean, the beauty here, of course, is that it kind of doesn't matter, right? So if you've got a preference for one development tool or the other, go with the one that you like. If you're talking about where do I see that data, we've obviously chosen to go with an Instana-based approach just because that's IBM's premier solution that's focused very much on observability across every piece of software that IBM provides. If we're talking about what's happening kind of middle of the year sort of time frame with our hybrid IPaaS efforts, the likelihood is that we'll have some observability views there to show as well. And we've got our public preview of that code coming very shortly. The timing didn't quite work for us this week to be able to put that in front of folks, but very similar concepts. Some of the views that Ravi was showing in some of his charts there, where you've got the wiring diagrams to show the different components, not just the flow services, but everything that's wired together. When you're sending that data between ACE and webMethods, you can then view inside those hybrid IPaaS charts exactly where the data is and how long it's spent in every location. So I think in the long run, Frank, you may not even need a specialized tool like Instana if you're only interested in the products that make up your hybrid IPaaS or your integration estate. If you're interested in something that's a bit of a wider view, or if you've already invested in the technology, or you love the fact that those very specialized views we've been showing today gives you all of the different drill-ins and the filtering and the different time periods, performance, then yeah, there's a professional tool. That one might be a better choice. I've done what all architects do, and I didn't say one or the other, right? They're both good. Yeah.
Yeah, and to
One
generally
architect, 5 opinions. Yeah.
Yeah, and to generally respond from a webMethods perspective, when we're going down this road of OpenTelemetry and how do we best approach our customers with it, we wanted to provide an approach that is completely customizable, allow customers to come to it with, if they want to come roll up their sleeves and put in exactly how they would like each trace to be handled, they can do that. But if they want standardized approaches with messaging or streaming like Kafka, or use a platform like Instana or Dynatrace or any other platforms that are out there, we want to go ahead and support that. So we don't for really is preach about saying you have to use X or Y or Z. I think it's good that we do that because it allows customers to make their own decisions.
Good. We do have a question. It's webMethods. Is there a capability to selectively enable webMethods services for OpenTelemetry?
Yes,
so instead
absolutely.
of doing everything, I just want to watch.
You can specify the services, and also, if you don't want all top level services to have instrumentation done, you can specify a subset as well. Yeah.
Okay. And this is always the paranoia on observability. Do we have any concerns about performance? I know the answer is no, but
yeah.
That is something that everyone always thinks of as, oh my God, you turned logging on production, we're all going to die.
So, yeah, absolutely. So from our perspective, we've come to this end-to-end monitoring agent from the experience of running it for customers that have millions of transactions day on day, month on month, right? So that's definitely one of the key things that always is asked about. Hey, I'm running this this additional overhead of some level. How do we know that it's not going to impact transactional capability of the systems, right? So, and that's something that we've evolved in terms of the years that we've had end-to-end monitoring in place. That's something that we always look at in each release, and we have test sets for in terms of performance and concerns around it, right? So it's an evolving thing that you have to always keep your eye on with each release in terms of anything like this, in terms of agents. And that's what we do. So we do our best, obviously, to help monitor the performance of our agents and the overheads that are being presented when tracing is enabled. So that's, from our experience, that's the best we can do, and to understand and make sure that there's no scenario where transactional capabilities impacted as a result of tracing being enabled.
I'd second that, but just one additional thing. There is pressure constantly from tooling vendors, and Instana is within IBM, but it's still a tooling vendor, to try and furnish extra drilling information in each one of the spans that goes across. And we've been adopting quite a hard architectural line on this, in that we want those spans to ultimately put our products in the best light possible. So we want to put extra info in there. And in the examples we were showing in the UX there, you'll have seen, the node name, the flow name, the transport, the status code returned. There's a bunch of information that's already there in that data. But when somebody starts asking me for, oh, could you just put that 2 meg payload in there as well, please, so that I can get a lovely view of the drilling? The answer is no, right? So what you're likely to see in the future from an evolution point of view is we are keen to give better drilling information, but the way that we do that is essentially carry a link in that OTel data, and then the link will be a key to some other system. And a lot of our users have already got those business transaction monitoring, record and replay. They've got databases coming out their ears with the data as it entered their system. So really, I think that's the way we should think about it. For drilling, OTel isn't appropriate to carry that in every single span, but linking back to other systems and having a syntax for what those URLs should look like, what their web links should be like, I think that's going to be quite important as we move forward.
We have a question from Melis. Hey, Melis. I'm not an expert in OTel, so maybe you've already covered it. What would happen in a situation where an application uses various integration products, but only some of them implement the OTel standard? What would be visible or not in the dashboard? So you're going to end up with a bunch of unknowns or blanks, or how would that work, where you've got a mix of OTel friendly and OTel not working?
Absolutely. So you're only as good as the data that comes back to you, Melis, right? So the short answer is if it's an HTTP client and it's clever enough to copy headers back, then at least you know the same span ID, even if nothing further has been furnished into it. But if it was, for example, deleting the request entirely and sending back some other entirely non-affiliated response, we wouldn't know any the wiser. Now, in the case of HTTP, where you've actually got a client socket open, you know what's coming back came from the place that you sent it. But if it was an asynchronous transport, you of course don't know that. So we're reliant on that header data being copied over. And there are some cases, for example, with some mainframe applications that can talk to MQ, for example, where they're not able to cope with an RFH2 header structure. So we do have some of those situations where you have a gap in your trace. It doesn't mean that you lose context for any further item, because again, if you've got Ace that's calling one service and calling another, he can make those calls with the same span ID inside both of them, and it doesn't mean that the second guy is not going to get it. But if the first guy received that request and then he's got 3 other services that are dependent on him, that's a black box from my viewpoint at that stage, because I don't know what else has happened lower down the line. So it's a very astute point, Melis, that we're only as good as the data that's flowing across. It's by carrying those spans and the trace parent identifiers through the whole architecture. That's how the linkage and the correlation is actually happening.
Yeah, and I would say I will add certain vendors, and I'm not going to classify which vendors and which do this and they don't, are smarter, to take, for example, a chain of known sequence of what you're expected to get, and understand when that expected event doesn't get met, and be able to create alerts and do things like that. So there's actually the blank box in that case. It's not necessarily a death knell, because you have an expected stuff that happens before the black box, stuff that happens after the black box. And if you're able to confirm that that transaction's gone through its proper life cycle, even without knowing the black box, you can kind of say you're okay. Whereas if there's something missing, something different, highlighting making rules and alerts based on what's not there that you expect, that changes. That's dependent on the vendor. But sometimes the black box is easier to handle, and sometimes it's harder to handle.
Yeah, makes a great scapegoat. It's not our stuff, as you can see. It's those guys.
Yeah, actually, it's interesting.
Scapegoat, right?
It's very interesting, because I think one of the common things that I hear from customers is, because you're in this integration sphere, you're always held responsible. All of our customers are said, hey, even if the application's not working, right, downstream point application's not working, what's seen as we're not able to deliver, right? So that mediator kind of aspect of the work we do in the integration space is naturally where the question is going to go. Hey, ask them why this is not working, right? So and it's a very natural thing that we see over and over with our customers.
Yeah, good point. We've got a couple of minutes left. Just a reminder, everyone, office hours later today. Ben, I think you're double booked, so I don't think you're going to be on that one, unfortunately. Robbie will be there. And also Tech Community for ongoing Q&A and blogs and everything else on this. And also in the session catalog itself, access to the materials and the videos of all of this. Another question from Melis, which is good. Would you say OTel is really picking up as a de facto observability standard?
Yes.
Absolutely.
There you go. Thank you.
Well, I mean, it's fascinating when you look at all these different standards and some of their lifespans. I mean, in this particular case, if you just take a look at the vendors that are now supporting it and talking about it, this is one that is definitely here to stay. Everyone has really thrown their weight behind this effort. So yeah, there you go. You heard it from me. This one's not disappearing. Plenty that do, but this one's not. It's going to be here around for some time.
Yeah, I'm curious to see if this will extend into things like IoT, for example. Will we actually end up with proper standards for IoT device communications, because it's telemetry in a different way? But that's one of the problems I've seen over in IoT, is that lots of stuff all happening at the same time. How do we put context around all of it, and because that ends up flowing through application integration from my past, and you need to be able to trace it back. So where the heck did this come from? Why did we do this? And one of the issues is I've seen is a lack of standards for communication. So if we see this being applied across the board, then that's a huge plus. That's what I'm hoping for.
I think what they've actually done quite well in this example is that they've managed to say, thou shalt include these particular identifiers when you're sending the data through, but then also not strangle the vendors. So if you want to add additional value as a vendor, you can put additional detail into the other fields, which may not be mandatory from one product to the next. And you compare webMethods and ACE, we've got different terminology for some things, right? Whether it's a message flow or called a node or called a server, there's a bunch of different things there. So which values that you'd carry from each of those different circumstances, they're just going to be different, right? So that's something where the spec has not put its nose in too deeply and has allowed people to evolve and to make their own tool better than the guy they're competing with, right? So I think that's probably also been behind some of the success of the standard this time around.
Yeah, very good. We're just coming up to the very end of the session. I'm just checking again. Melis again. Does that mean IBM is implementing it in their complete product line? This is in comparison to last year when each product team could make a decision individually. Is it the standard for IBM really across the product line?
I'm struggling to think of any IBMer that would be willing to say the whole of IBM is definitely doing this. So if we narrow that slightly, Melis, and we meet in the middle, from a CloudPat point of view, yes. So CloudPat for integration was pushing this across each of its products, and that was the reason why we did it as a block over the last couple of years, right? So yeah, I don't think I could honestly look you in the eye, Melis, and say the whole of IBM. But yeah, if we say the whole of integration, let's put it that way. Yeah, meet in the middle.
Yeah, and we'll just peer pressure the rest of them. So yeah. All right, thanks guys. Very good session. And we are concluding right now. I think I've got one more left to go today. But yeah, great Q&A. The information will be available for everyone on the website, session catalog, and the slides are at the bottom of this page if you're looking. Okay, thanks all. Bye now.
Bye, guys.